right, so the goal of these next 5 or 6 problems is for you to practice these composition limits or limits of composition or composite functions yourself first. And then listen to me solve them, because it's tricky. It's a tricky concept, so I'm going to repeat a little bit of what we do. So just a tiny recap, even though we just did it. So we're approaching some constant. For the heck of it, I'm going to say 2. And we have some function inside of another function. Remember our steps. The first thing we do is we sort of just push this limit out front or out of the way, and we take the limit as x approaches 2 of the inside function. If that limit doesn't exist, meaning if on the function g we approach 2 and we end up at 2 different y values or 2 different heights, so basically you see a gap in the graph, our answer is D and E. If the limit of the inside function doesn't exist, the limit of the composite function doesn't exist, okay? But if the limit did exist, so let's suppose, back over here, we approached 2 and we ended up at 1. Then what we do is we look at what happens to the limit as x approaches 1 on the function f. Now, if f is continuous at 1, basically you don't lift your pencil, then your answer is just f of 1, okay? If the function is discontinuous, then we have to decide if we're looking at approaching 1 from both directions, from above or from below, okay? And that's why we're doing these extra 6 problems, because that's kind of a lot to keep track of. So I would challenge you to try question number 1 on your own, using your new learned knowledge from your notes and what we just talked about, which was a little recap, to decide what happens as we approach 1 to the function f of g of x. You try it on your own, and then check it with this video. All right, so now that you're back, let's see how you did. First thing we do is we take a look at what happens as we approach 1 from both directions on the function g. So here's g. I'm approaching 1, and I'm approaching, I'm approaching 1 from both directions. I'm up at 3 and up at 3. So my limit is 3. And when I go take a look at what happens, at 3, the function's continuous there. So I can just say my answer is f of 3, which is 0. So this was nice because the limit existed here, no discontinuities here. So basically we were able to say that it was the f of the limit as x approached 1 of g of x. And this was 3 and f of 3 was 0. So that was the best case scenario. The limit existed, and on the next function we had continuity. That's called La La Land. That's awesome. We like that. All right, so our next one is, well, what's happening as we approach 2 from both directions? First of all, we focus on f. So I'm going to hop on the f graph, and I'm going to approach 2 from the left and from the right. F graph, 2 from the left, 2 from the right. This does exist. The limit is 2. Okay, so now I'm going to see what happens as I take the limit as x approaches 2 on the inside function, and now I have a problem. I don't say D and E though, because I have to go back and say, well, how am I approaching 2 over here? And you'll notice I'm approaching it at 1. I'm looking at those y values. I'm up at 1.1, 1.5, 1.8, 1.9, 1.99999. I'm always approaching 2 from the left. So in blue, I'm going to put a little left there because I'm approaching from below. So that means when I go over here, I look at what happens on g as I approach from the left, and I'm at -1. So that's when it gets tricky. Our limit did exist, but then we had a discontinuity. Now keep in mind, had this function over here, f gone like this. Then when I say, how am I approaching 2? I am approaching it from both directions. Then I'd have a D and E. Okay, so you have to decide from above, from below, both directions, or one of each. So question number 3, again, you try it and then you check it. You're doing a little bit of a self-reformative check here. So let's pick up the pace here. Let's approach 2 both directions on the graph of G. Approach 2 from the left, approach 2 from the right. My limit is where I am on the y-axis there. It is 1. So now I'm going to look at what happens as I approach 1 over here. Uh-oh, discontinuity. So I go back to the original graph and I say, well, how was I coming in at 1? I was coming in at 1 from 3, 2.9, blah, 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 blah. I was coming in from above 1, 1.1, 1.11. So over here, I'm going to approach 1 from the right-hand side. Again, above, right, below, left. One of each, D and E. So this answer would be 2. Question number 4. Again, you try it, you check it. Okay, so here we go. These are actually kind of fun once you understand them. You feel kind of smart. So I'm going to hop on the graph of F. And I'm going to write this one as if it was an FRQ and I had to show all my work with great notation. I'm going to take the limit as x approaches -2 of the inside function. So I'm approaching -2 from the left. I'm approaching -2 from the right. And this doesn't exist. So this is a case where I get to stop and I get to say, if the inside function's limit doesn't exist, we quit. The composite function's limit would not exist. So, done with that one. Number 5. Again, another function composition, and we're approaching -2. In this case, we're looking at the graph of G. We're approaching YG because we go to that inside function first. We basically just push that other one out of the way. And we're approaching -2 from both directions. That limit does exist. I'm down at -2. So then I head over to this graph and I approach -2. And I have a discontinuity. So now I have to go back over here and say, well, from which direction am I approaching -2 from? And the answer is both directions. So I have to come in from the right. Why both directions? From above it and from below it. It's not one of these where I'm always above it. And by these, I mean, I just kind of said, well, what if this wasn't here and the graph went like this? Then I just come in from the right. Above, right, below, left. In this case, we from above and below. So when we approach -2 from the right and the left, this is a non-existent limit composition. All right, now we just have one graph. And again, you try it on your own first, otherwise you're not getting the most out of this exercise. So let's hop on the only graph we have. We're going to approach -1 from both directions on the graph of f of x. Approaching -1 from the left, -1 from the right. The limit exists. I'm up at 3. It's not there, but I'm there. Okay, so 3. So then I hop on the outer function, which is also f, and I look at what's happening in that 3, and I have this discontinuity. So again, I have to decide back on the other part of it, the inside, was I approaching from above the right, below the left, or one of each? Well, I'm approaching from below 3 on this side and below 3 on this side, so I only approach 3 from the left, and that puts me at -2. So I think that's it. So hopefully you have that down. They're kind of fun once you get them. Have a good one.